Hello, welcome to this third video on normal distribution. In this video, we are going to solve three problems using normal distribution. Let's begin with the first example. The average per capita spending on healthcare in the United States is $5,274. If the standard deviation is $600 and the distribution of the healthcare spending is approximately normal, what is the probability that randomly selected person spend more than $5,800? So here they have given mean. This is your mean, and this is the standard deviation, and the distribution is approximately normal. So this is the normal distribution, but not the standard normal, because mean is not 0 and standard deviation is not 1. But in a normal distribution, mean is always here at the center. So that is your 5,274 or 5,274. And you have to find the probability that the spending is more than 5,800. More than 5,800, that's from 5,800 all the way to infinity. Okay, so that probability is equal to this area under the curve from 5,800 up to infinity. Now, in order to find that area, if you remember, we can use our calculator. So probability that x is greater than 5,800 is equal to, you can use calculator to find normal CDF. The lower end for that area or the lower boundary is 5,800. Upper boundary, it goes up to infinity. So we write E99 for infinity. Mean is 5,274. And the standard deviation is 600. Okay, in order to find this value, we use our calculator. So if you go to your calculator, then second vars and number 2, your lower end is 5,274. Hold on, your lower end for the area is 5,800. Okay, the upper end is infinity, that is E99. So to get E, we type second and comma, E99. Mean is not 0 now, mean is 5,274, and standard deviation is 600. Now select this paste, hit enter, and enter one more time, and your result is 0.1903. So probability of spending greater than 5,800 is 0.1903. Okay, 0.1903. So this is normal distribution, but not the standard normal distribution. Everything is same. In place of mean, we have 5,274, not 0. In place of standard deviation, we have 600, but not 1. Okay, let's go to next example. Example 2. The average number of milligram of sodium in certain brand of low salt microwave frozen dinner is 660 milligram. So that is the average amount of sodium, mean. And the standard deviation is 35 milligram. Assume that the variable is normally distributed. So this is the normal distribution with a mean of 660 milligram and standard deviation is 35 milligram. If a single dinner is selected, we have to find the probability that the sodium content will be less than 650 milligram. So we are looking for the probability that the amount of sodium is less than 650 milligram. Okay, less than 650 milligram. So what do? The mean is always here at the center, which is 660. 650 should be somewhere here. So this is this point here. This one is 650 milligram. we have to find the probability that the amount of sodium content will be less than 650. Less than means this side, less than 650. So the probability that the amount of sodium is less than 650 will be equal to this area here, equal to this shaded area. And we know that in order to find this area, we can use our calculator, normal CDF in our calculator. So this must be equal to, we have to type this in our calculator, normal CDF. Lower end, you can see lower end for the area is negative infinity, which is negative E99. Upper end for this area is 650. Mean is 660. Standard deviation is 35. Okay. So if we type this in our calculator, let's see what we get. So we do second, and then vars number 2. Lower end is negative infinity, so negative. Second and comma, that will give you E99, negative E99, that's negative infinity. Upper end for that area is 650. Mean is 660. Standard deviation is 35. Select that, paste, enter, and enter one more time. So you'll get 0.3875. So that is the probability that the amount of sodium content will be less than 650 milligram. Okay. 0.03875. So that is the probability that the amount of salt or sodium will be less than 650 milligram. So that is the second example. Now let's go to the third and the last example for this short video. Here is that. Example 3. The average height of certain age group of people is 53 inches. So average, that's your mean, 53 inches. Standard deviation 4 inches. And the variable height is normally distributed. So this is normal distribution with mean 53, which will be right here in the middle. Okay, standard deviation 4. Now we have to find the probability that a randomly selected individual's height is between 51 and 57. 51 should be somewhere here. This is your 51. 57 should be somewhere here. So what is the probability that someone's height is between 51 and 57? So if I want to find this probability, this will be equal to this shaded area. Okay, the area bounded by those two values, 51 and 57, under the normal curve. So I'm looking for this area. That will give you the probability. So let me write that here. Probability that the height is between 51 and 57 is equal to, you know that you can use calculator to find this. So this is equal to a normal CDF. Lower end is 51. Upper end is 57. Mean is 53. Standard deviation is 4. Now we can type this in our calculator. Okay, let me grab that calculator. So in order to type that, we press second, vars number 2, lower limit for the area, a lower boundary 51, upper boundary 57, mean is 53, standard deviation is 4. Select the paste, hit enter to paste that on the main screen of the calculator, and hit enter to calculate that, which is 0.5328. So probability that the randomly selected individuals have a height between 51 and 57 is 0.5328. 0.528. Okay, that is 0.5328. So this is the end of this short video. Thank you for watching.